So hi guys, for tonight's lesson I want to talk about the diagram up above so you can look at it. And what I want to tell you is that chord XY is a diameter. Alright? And I want to tell you that AB, line segment AB, is just a chord. And I want to give you some relationships between diameters and chords. So the first thing I want to say is that if you have a diameter that is perpendicular to a chord, so the way I have it in the diagram, I have XY is perpendicular to AB. So if you have a diameter perpendicular to a chord, then something happens. And here's what happens. The two pieces that the chord is cut into are actually equal. So in other words, the diameter bisects the chord. So the rest of the theorem, the way you want to say that is, if a diameter is perpendicular to a chord, then the diameter bisects the chord. And that's the theorem. So the second part of the theorem says that if you have a chord that is cut by a diameter into two equal pieces, so in our diagram that would be AZ is equal to ZB, then that diameter must be perpendicular to the chord. So it's just the reverse of the original theorem. So how would you write that? If line segment AZ is congruent to line segment BZ, and the diameter intersects at point Z. Whoops, that's not a Z. This is a Z. So that AB is bisected, then the diameter is perpendicular to AB. And that's the second part of the theorem. So you can see here that we have a whole problem set up. Notice that we have a diameter, CD, that is perpendicular to a chord, AB. And by this arrow right here, you can see that AB, this side of this side here is 5x minus 16, and this side over here is negative 2x plus 12. So by the theorem, we can say that these two pieces are equal because the diameter is perpendicular and bisects the chord. And so therefore, we can find x by setting up 5x minus 16 equal to negative 2x plus 12. And if you add 2x to both sides, and then add 16 to both sides, then what you will end up with is, up here, 7x equals 28, and then divide by 7, and you get x equals 4. So that answers the first question, find x. The second question is find AB. So once you find x, then you need to plug x in to both of these, because added to these two pieces added together, let me demonstrate that. These two pieces added together, this piece here and this piece here added together are going to be the total of AB. So I would take x equals 4, and I would go 5 times 4 minus 16 plus negative 2 times 4 plus 12. And adding those together, I get 20 minus 16 minus 8 plus 12, and that gives me 32 minus 24, or 8. And therefore AB is equal to 8. So this problem shows us that there are two parts to the problem. You have to solve for x, and then sometimes you have to solve for the length of a segment. So here's a tricky one. Why don't you give yourself about 2 minutes to solve this. In circle H, the diameter is 18 and LM is 12, and the measure of arc LM is 84. Find the measure of arc LK and HP. So pause the video, give yourself a couple of minutes, and then come back and see how you did. So let me show you how to do this, and you can check your answer. So let's find the arc LK first. So what I notice about arc LK is that it seems to be the half of arc LM. Now, can I know that for sure? And the answer is yes. For instance, what I notice is that right here is a chord, and right there is a chord. And since this diameter is perpendicular to that chord LM, that means these are right angles right on the bottom. Let me show you those again. I'll show you. These are right angles. So this one and this one right there are right angles. And since those are right angles, we have two right triangles that are going to be congruent. How do I know they're congruent? Well, this side is the same side as itself. I have a right angle here, a right angle there, and this side are the two pieces, LP and PU, that are bisected by the denominator, which is what the theorem told us. So now, since I know that, by a side angle side congruency theorem, I know the triangles are the same. So the question then becomes, because the triangles are congruent, then the two original green pieces right there and there, they also have to be equal. And if chords are equal, then arcs are equal. So therefore, arc LK and arc KM are the same, and in a very simple way, to find the measure of arc LK, I just need to say that it is 1/2 the measure of arc LM. So that's 1/2 times 84, which is 42 degrees. So let's do the actual tricky problem at this point. And I am going to move this off screen. Isn't that nice? So it's out of my way. And what we want to find is the length of HP right here. Now, what I'm going to do is I'm going to label HP X, And then I know that the whole diameter is 18. Therefore, the radius is 9. So therefore, I can label this little piece in black as 9 minus x. Because x is all of HP, 9 minus x is that little piece. And then I also know that because HK or JK, the diameter, bisects LM, the chord, and I know that the chord is 12, I know that this piece is 6 and this piece is 6. And therefore, if I complete this little triangle here, and I look at this triangle here, what I have are two right triangles with Pythagorean theorems that give me some interesting things. But the real key one to look at is this right triangle over here. The one, I'm going to trace it for you. So here I go. It's this one. See me tracing that in red? That right triangle is the one to look at. The reason is because HL is a radius, and that radius is equal to 9. And therefore, in the right triangle, I know two sides, and I want to find HP. And so I'm going to find x first, the little green part of that right triangle. So it becomes a Pythagorean theorem. 9 squared equals 6 squared plus x squared. And that's 81 equals 36 plus x squared. Subtract 36 from both sides, and I get 45 equals x squared. And so the square root of 45, which is equal to 3 times the square root of 5, so make sure you can think about why that's true, is equal to x. Now that I know x, I can now come in here and find this little piece right here, this little black piece right there, which earlier I labeled as 9 minus x. Well, I know what x is, so if I take 9 minus that, that will give me, oh, actually, pardon me, folks, I have already found HP, because HP is equal to x. If I wanted to also find PK, then I would do 9 minus x. And some problems do ask you to do that, so I apologize. But that would be 9 minus x, or 3 square root of 5, for PK. So PK is this, and this is HP, which I already found. So it becomes a Pythagorean theorem problem. A little bit tricky, that's why I wanted you to think about it. So to finish this video up, what you notice is that I have two chords, and then I have two pieces of a radius that are perpendicular to them. Well, when short lines like this are perpendicular from a point to a line, in this case from the center of a circle, which is point P, then those short pieces are called the distance. So anytime I want to go from a point to a line and find the distance, I do a perpendicular. That's all I'm doing there. And if I were to label these both 4 centimeters, then that would mean that the two chords are equidistant from the center, which means they're the same distance from the center. And if chords are the same distance from the center, then the chords are congruent. And that's the last part of the theorem, and you'll see some problems where you have equal distances or congruent chords, which means the distances are equal. And both of those things help you solve problems similar to what we've done. Thanks, that's the end.